the integral of 1 over x dx, and don't forget 1 over x is just simply x to the minus 1, the same problem we were just working a minute ago, is defined by definition to be the natural logarithm of x. And of course you have a constant just like you do for any derivative. I'm sorry, for any integral. So this is something you need to remember. Remember this, okay? It's something that you're going to need to work with on your test. And this just is simply done this way because when you try to apply that polynomial formula for x to the minus 1, it just doesn't work out. You get some nonsense answer. And you can go and you can look in your calculus book and figure out why this is equal to the natural logarithm of x. I don't see that as my job here. I see my job is to teach you how to work problems. But this is the result. This is what you need to remember. Now, because of this, as a direct result of this, you can also say that the derivative with respect to x of the natural logarithm of x is just simply equal to 1 over x, like this. Okay? So these two things I'm going to put over here on the side, and these two things we're going to use in this section over and over and over again, and you're going to use them in your class over and over again. Now I've got a couple of asterisks here, but I'm going to go ahead and erase those for now, just so no one gets confused, and so that we all know that this is what we need to know here. And just convince yourself that this is true. Because the integral of this is this, that means the derivative of this must be this, and that's the only thing we're writing down here. So what it tells you is anytime you come across the integral of 1 over x, you know what the answer is, and anytime you come across the derivative of the natural logarithm, you get 1 over x. And you can go and look in your book, if you're not sure what the natural logarithm is or how it's defined or what it means, you can go back and look at a pre-calculus book, or you can look at my video in pre-calculus, and we'll work a bunch of problems and actually describe what the natural logarithm represents. But it's just another graph, it's just another function defined in terms of the logarithm with a base e. So let's go ahead and work some problems. What if you were given f of x is equal to x to the 1/2 power, in other words the square root of x, times the natural logarithm of x, and this is your function, okay? And they say, well, give me the derivative, f prime of x, okay? And you're going to have to find that derivative. Well, the first thing you should notice is that you have a function of x times a function of x, so you're going to have to use that multiplication rule. First term times the derivative of the second term plus the second term times the derivative of the first term. So let's do that. You have the first term, x to the 1/2, times the derivative of the second term. The derivative of this is just simply 1 over x. Right? First times the derivative of the second plus the second term. Okay? I'm going to go ahead and put brackets around everything so that we're very clear. The second term times the derivative of the first term. We know how to do this. We've been doing this all day. This is just 1/2 x to the negative 1/2. 1/2 comes down, x, and then you just subtract 1 off of the exponent here. So essentially this is the answer, and you just need to go ahead and simplify that, right? So what you're going to have is, you're going to have x to the 1/2 over x, which will be this part here. You just multiply these two things together, plus natural log of x over here over 2 times x to the 1/2. And all I did was I left this on the top. This 2 is of course on the bottom because you're multiplying them together. And this x to the negative 1/2 just goes down to the bottom, downstairs, and you make it a positive term there. So what you're going to have here, if you simplify this, is when you simplify this guy right here, you're going to have 1 over x to the 1/2, because basically I can take out a 1/2 from there and I'll have a 1/2 left over in the bottom. And then over here you have the natural log of x over 2 times x to the 1/2. Now this is basically the answer, and you could circle that as your answer, but if you wanted to tidy things up just a little bit, then you could try to get a common denominator here, and the simplest way you could get a common denominator is just to multiply this fraction by 2 over 2, which of course is just 1, so I haven't changed anything. So what you would get is 2 over 2 times x to the 1/2 plus natural log of x over 2x to the 1/2. Okay, now I have a common denominator, and then I can just write 2 plus natural log of x over 2 times x to the 1/2. And then that would be my answer. So you see, it's the same old story as before. You're taking a derivative using that multiplication rule for derivatives, but now you have a couple of additional tools in your box to actually evaluate that derivative of the natural logarithm, which is really what the problem's about.